Welcome to the explainer. Okay, so if you've ever used Kubernetes, you've typed kube control run, right? But have you ever stopped to think about what actually happens after you hit enter? Well, today we're going to pull back the curtain and look at the real engine doing all the heavy lifting, the container runtime.
All right, to get started, let's picture this. You walk into a super high-tech kitchen and you tell the chef, cook me 3 portions of Nginx, 1 database, and 2 background workers. Now, this might sound a little strange, but it's the perfect way to think about how Kubernetes works. Why? Because the chef doesn't actually do any of the cooking themselves.
So here's what we've got on the menu for this explainer. We'll start with that kitchen story, then we'll meet the actual robots doing all the work. We'll break down exactly what their jobs are, see how they all plug together, and then we'll do a reality check on what's actually running in most clusters today. All right, let's jump right into this kitchen analogy. See, in the world of Kubernetes, there's a really clear division of labor. So the big question is, who's the chef that's calling out the orders and who's the one actually in the back, lighting the stove and getting the work done? And here's the absolute key takeaway, the one thing you really need to get. Kubernetes itself, it doesn't run your containers. No way. It's more like a manager or our chef, just giving out high-level commands. All the actual low-level nitty-gritty work, that gets handed off to a specialized tool. That's our kitchen robot, the container runtime. So let's get a little more specific. What is this container runtime? Think of it as the real engine humming away on every single node in your cluster. It's the thing that takes direct orders from the kubelet, that Kubernetes agent on each machine, and it's the one that does all the essential jobs to actually bring your app to life. Okay, but here's the thing. Not all of these kitchen robots are created equal. I mean, they all basically do the same job, but there are a few different players in the container runtime game. So let's meet the main ones you're going to bump into in any modern Kubernetes setup. So take a look at this. It's pretty obvious who the winner is here, right? Containerd is everywhere. It's basically become the industry standard, and for good reason. It's super lightweight and does one thing really, really well: run containers. Of course, you've also got CRIO, which is kind of like its cousin, built just for Kubernetes. And then there's the old famous one, Docker. And its whole story with Kubernetes is a really important part of how we got here. And this timeline really shows that big shift. For the longest time, Kubernetes needed this special little piece of software, the Docker shim, just to be able to talk to the Docker engine. It was like a translator. So when Kubernetes finally decided to remove it, it was a huge deal. It made Kubernetes itself way simpler, and more importantly, it forced the whole community to move towards a universal standard. That's what really opened the door for these focused, lightweight runtimes like Containerd to take over. Okay, so we keep saying the runtime is the engine, but what does that actually mean? Like, what does it do step by step when the kubelet taps it on the shoulder and says, "Hey, run this container for me"? Well, here they are, the 7 core jobs of a container runtime. It all starts with pulling the image from a registry. Then it has to build the container's own private little world. That means setting up the file system, creating total isolation with something called Linux namespaces, and then putting up guardrails on resources with C groups. Only after all that does it hook up the networking, fire up the application's main command, and, of course, clean up the mess when it's all over. Let's double-click on that third step for a second, the whole namespaces thing, because this is where the real magic of container isolation happens. Linux namespaces basically create a bubble, a complete virtual world for the container. With its own PID namespace, the container thinks its main process is process ID 1, the most important process in the universe. With its own network namespace, it gets its very own IP address. It's this incredibly clever, deep-level trickery that makes the container feel like it has an entire machine all to itself. Okay, hold on. We just said there are different runtimes, right? Like Containerd and CRIO. So how on earth does the kubelet talk to all of them without needing a bunch of custom code for each one? Well, the answer is a really, really smart piece of engineering, the Container Runtime Interface, or CRI for short. The easiest way to think about the CRI is like a universal language. It's a contract. The Kubernetes team basically sat down and defined a standard set of commands, things like run pod sandbox and create container, and then they said to the whole world, hey, if you want to build a container runtime that works with Kubernetes, it has to speak this language, no exceptions. And this analogy of a universal plug, it's perfect. It's the key to the whole thing. The kubelet is just an appliance, let's say a toaster. The toaster doesn't care if the wall socket was made by GE or some other brand. As long as the socket has the right shape, the right standard, you plug it in and you get toast. It's the same here. As long as the runtime, whether it's Containerd or CRIO, is built to the CRI standard, the kubelet can plug right in and everything just works.
Okay, so this isn't just theory, right? This whole system is running on your clusters as we speak. And the cool part is, you can actually peek behind the curtain and see it for yourself. So let's talk about the tool that lets you do just that.
So the question is, how do you actually look under the hood of a Kubernetes node and find out which kitchen robot is doing all the work? Well, it turns out there's a special tool designed for exactly that. And that tool is called CryoTool. It's a command line tool that lets you talk directly to the container runtime on any node. You're completely bypassing the main Kubernetes API and talking to the engine itself. You're literally speaking the exact same CRI language that the kubelet uses.
For example, when you run a command like cricktl ps, you're not going to see Kubernetes pods. What you'll see are the raw individual containers that the runtime is actually managing. And that right there is proof that there's this whole other layer working away underneath Kubernetes. You can use it for all sorts of stuff, listing images, pulling new ones, checking logs, all at that low runtime level. And this right here is your 2025 reality check. It's a containered world, we're just living in it. Seriously, whether you're on GKE, EKS, AKS, or even just running a little local cluster with Kind, the engine under the hood is almost certainly containered. The big exception, of course, is OpenShift, which uses its close cousin, CRIO. But honestly, that just proves how successful the whole standardized CRI idea really was. So let's put it all together. Here is the full chain of command, from you to your running app. You type kubectl. That goes to the kube API server. The API server tells the right kubelet on the right node what to do. The kubelet then translates that into a CRI command and tells the container runtime. And it's the container runtime that finally does the actual work to get your app up and running. Phew!
And really, this quote just says it all, doesn't it? The container runtime is the real engine. Kubelet is just the manager who tells it, start this or stop that. That is the core idea to take away from all this. We talk to Kubernetes, but the container runtime is the one actually doing the work. You know, getting a handle on the container runtime is a massive step towards really mastering Kubernetes. It makes that whole separation of duties crystal clear. But it also makes you wonder, right? If the runtime is the stove, then what about the plumbing for networking? Or the pantry for storage? Or the head chef deciding which orders to cook next, the scheduler? What other critical parts of this kitchen do we need to explore?